Okay, let's get to it. So, earlier we made some. We wrote some code in a very generic way in C99 so that it would be easy to cut and paste that code into GLSL. So what you're seeing here is a big huge shader string of a whole bunch of functions that were originally written in C code, and now they're just pasted directly into the GLSL and they're just working properly. And we had to do some tricks to get that to work. For example, we have this little macro, AAC 2020 macro. This is OpenGL. And if it is OpenGL, then all of these different defines will be specific to GLSL code. So U32 is a uint versus a uint32 underscore t. This TF for texel fetch is the actual inbuilt texel fetch in GLSL here, whereas over here it's a polyfill called texel fetch. P5D here is our texture sampler for the PAINT5D memory, but over here it's just a 0 because we don't actually use it. Same thing with sampler. Sampler is a usampler2D in the GLSL code version, and in the C code it's just an integer, right? And then some defines for an unsigned integer 0. In C code, we can just do this, but in GLSL, we actually have to use kind of like this constructor kind of thing here. So yeah, so just this little, you could call this like a little adapter if you want to call it that. I don't know what we want to call it. I don't know if shim is the right word. Let's look up what shim means. Shim in code. A shim is a library that transparently intercepts API calls and changes the arguments passed, handles the operations itself, or redirects the operation elsewhere. Shims can be used to support an old API in a newer environment, or a new API in an older environment. Shims can also be used for running programs on different software platforms than they were developed for. Running programs on different software platforms than they were developed for. So yeah, we kind of do have a shim, right? Because we're taking C99 code, right? So you could think of the platform as C, and we're taking that C99 code and we're running it in GLSL, right? So it is actually, a shim is a pretty good definition for what we're doing. So hold on, shim Wikipedia. So I will accept that we are using the word shim correctly. Let's look at Stack Overflow. Definition of a shim from Wikipedia. Well, you already read Wikipedia. Yeah, I'm very surprised that we got 97 upvotes and just cut paste from Wikipedia. Like, damn. So that's how you get credibility on Stack Overflow. Been doing it wrong. As a structural design pattern. Yeah, I was calling it an adapter pattern earlier. So proxy adapter, facade, yeah, shim type functionality. Simple explanation via cartoon. Yeah, so yeah, it is a shim because we are intercepting a message. So let's just put this as shim Stack Overflow. Okay, yeah. So yeah, we are definitely doing a shim. And what I want to do is I want to make more shimmy stuff. So in this shader code here, our main function is this separate block of code here. Void main, and then we did all this kind of stuff. I'd like to get this working as GLSL or as C code. So let's create, let's try to, hold on. So let's try to do that. Let's, there's a whole bunch of stuff here from the old kind of shader that is going to be kind of useless as we start writing this new code. So really, we'd like to just kind of get rid of this whole thing and kind of start over fresh and put it into here, right? So let's try to do that. Let's, the first thing we're going to do is we're just going to do this. We're going to take this, and how confident do we want to be here? Do we just want to blast it away and be like, you know what? Forget about it. Just blast it away and... Well, we have a backup copy of it, right? So in this folder we have this version, whatever, right? This is the backup copy of what it originally was. So we have a backup copy. Let's just blast it away. And that'll just be a little bit easier because we don't want to maintain all this code that we don't really need. A null terminator here at the end. I don't really think we need this null terminator. I think I did that just in case. Here, let's make sure. Let's get rid of this null terminator, right? And see if possibly that wrecks our code, right? So just a little thing, a little sanity check before we nuke this out of existence. If we remove that null terminator character, does that have some kind of bad effect on the code, right? I don't think it will, but just make sure. Okay. So yeah, that's still oh wait, well, hold on. Before we confirm that it's compiling, we gotta delete it from here. Okay, now we gotta recompile. Okay, so let's take a look. It's still there. Okay, cool. So let's kind of just dump all this in the trash, right? So this whole thing, this main function, just be like, you know what? You're out of here. You're gone, right? All this stuff that was not from this void main. Void main, we're gonna yeah, you're out of here. Just bam. We're gonna nuke it. And we're gonna kind of put everything into here, right? We're gonna try to make everything into this one little payload that comes from the C file. So let's save that. And then over here, right, we'll just make another function. So we have all these different functions, this PAINT5D get, and we want another function called main. And it's going to be specific to GLSL, so we're going to call it, you know, we're going to name it OpenGL. We're going to keep the OpenGL namespace, OpenGL PAINT5D. And we'll call it main, PAINT5D main. Yep. And then it'll take right? So it'll take a void argument, but we'll have to change that. We'll use some macro magic, right? So, I believe if we, let's look at the old GLSL function. So if we look at this original version, right, and we look at main, let's see, like, well, how does main kind of work here? Void main, and there's nothing inside the parentheses, right? This is a little bit different than the C version of the code, right? So when we're writing this, we have to take that into consideration. So void, and this is a void argument, right? So let's go over here and undefine what we're about to define. Undef VA for void argument. Call that 11. Okay. And then up at the top, right, we could just go B3 to look for the VA. Yeah, so up at the top, right, if it is OpenGL, define void argument as just nothing. It's nothing, right? And if it is C code, though, the void argument is going to be void, right? So, see how we're kind of like making this we're making a shim, right? That is what we have decided we're doing, or that's what we have learned we are doing. We already were doing it. We didn't decide to do it just now. That's what we've been doing, but now we know what we're doing. Okay, so VA for void argument. And, we could make a note of what VA is for, right? So we could say, you know, VA, void argument. Okay. Then once we have this main, we could say, well, what's the quickest way to get something on screen, right? Like, the success of game teams at DigiPen was highly correlated with people getting stuff on screen right away, right? The quicker you have something on the screen and the quicker you have something to work with, the better of a situation you're in. Now, we already have stuff on screen, but as we're working on more features and whatnot, we want some type of visual screen kind of feedback. And we've been kind of putting that off by, like, writing all of this other code, but we really have enough to where we could start getting something on screen. So what I'm going to do is I'm going to look at the old code again and see how we're doing the frag color return, and we're just going to hard code some type of frag color return. We're not going to do anything fancy. We're just going to say, like, frag color equals vec4, whatever the heck, right? So we're not going to do anything fancy. We're just going to take this thing here and I'm just going to say frag color. Now, the problem with this now is frag color isn't really declared inside the function, right? It's right, frag color is, I believe, a define. It itself is kind of a shim of some sort. Oh no, frag color is right here. Out vec4 frag color. So it's kind of like in the function preamble. So if we want to get frag color, which is a vec4, to kind of work here, we need to we can't be declaring it, right? So because it is kind of like this specific thing, we could say, here, so let's take this if-def here. We could just pop it over here as well, right? We could say, you know, or actually it would be like if not def. So it'd be like, I don't want to get too fancy though, because I don't know if GLSL even has an NDEF. Let me check though. If NDEF GLSL, right? Does GLSL have one of those, or is that only C code? Okay. So yeah, if NDEF does exist, so we could make use of that. So we could say like, we could say like, if NDEF, right? If this is not OpenGL code, then we need to define this thing here, right? So we'll say, it's a vec4. So let's do fv4 for float vec4, right? Rather than doing, right now vec4 is implied, right? So vectors, implicitly, if the vector is, if the vector doesn't specify what type of vector it is, it's implied that it is a float, but I'd like to get rid of implications like that. So fv4 for float vec4 frag color, right? So we'll declare it if it is C code. So at vid IID 0093, and the time is 21:10, right? So what we're doing here is, frag color is an output parameter in GLSL, so we can't be declaring it within this main function if this is running as GLSL. But if this function is running as C code, then we're going to have to declare it as a float vec4. And frag color, we're going to use a vec4 constructor here. But we could do this. Float fv4 so there's a constructor. So this is the type, but this is the constructor. And we need to know the difference because, right, we don't have the ability to use that kind of constructor syntax in C99 code. So we'll need a kind of a polyfill for a constructor of this. Now, we could just long-handedly name it like this, fv4 constructor. So then over here, where we have all this code, we could do something like define fv4, so float vec4, And it's just a vec4, right? And that'll be the 12th thing. And then over here, FV4, if it's C99 code, is probably going to need to be one of these kind of struct things, right? Where we have a struct for specifically this type of polyfill kind of thing going on here again. So eventually these might have to be moved into a different file, because these are kind of very generic things that could be used in other cases. Yeah, but right now we'll just keep it here. But eventually we might need like an OpenGL sublibrary that's actually just these OpenGL shims, right? So this OpenGL shim is going to be FV4, floatvec4. So floatvec4. And let's look at these other ones, right? So we should have, yeah, these other ones already defined. So video 93, time is 24 minutes and 50 seconds. Alright, so we're just making another shim for output frag color, right? And I probably should have like a better way of writing these notes, because like this is kind of a bottleneck sometimes to like write these notes in here. And there has to be a better way, but for now, we'll just bite the bullet. So to get this working, we just need to take this and, oh god. We just gotta take this and, so that's why I do this, because I accidentally do the scroll bar if I, yeah, so we'll paste this here, and then this is, instead of UVec4, this is gonna be floatvec4 for RGBA normalized color. And that means that these things are going to be float32s. So F32 for float32, XY, ZW, same parameter names, just different type here. And then we will undef F32 here and then declare it up at the top here. So I don't know if we have a define for this. We're going to find out though, aren't we? We do, but that's not really... Yeah, I guess that's the best we can do for float, right? There's no, like, S in... Well, maybe there is. Maybe there's a header for that, but, you know, this is good enough. Yeah, because float is 32 bits. If you want 64 bits, you use something that has twice as many bits. Well, what's twice as many bits as a float? Well, it's a double, right? Because it's double precision. So that would be 64 bits. So I believe this will always be 32 bits, but it's kind of makes me uncomfortable not having some type of, you know, header to help with that. Because as you've seen, if you've watched this code, a lot of the mistakes that lead to a whole bunch of problems are wrong bit widths. So it's a big deal. So yeah, now we got this little thing here for float vex, so that's cool. And did we remember to undefine that, right? So down at the bottom here, do we have do we undefine it? No, we're still at VA11. And do we have 12 things now? Yeah, so FV4. So undef FV4. This is the 12th thing. Right, and they're just going to keep on coming. Because we also need a constructor, right? So, I think we're going to put that in another section, right? So, I'm going to call this constructor macros. And the reason I'm going to put it in another section is because it has a different, there's no way we're going to make something that's exactly 3 characters for this. So, you know, undef fv4 constructor, right? We could call it constructor like this. Or do we just want to call it like con for constructor? I don't know. This is obviously the most readable way to go. It's just that it's not very terse, and so I don't like it very much. If you think about general to specific, right, do we want to call this fv4 constructor, or do we want to call it constructor fv4? Well, since we already have this fv4 here, what comes after this fv4? Well, there's blank stuff after it. What comes after this fv4? Well, there's an underscore constructor. So with general to specific rules, it would make sense to name it this way, I think, rather than flipped around the other way. Now, let's just call it con for constructor, or we could say make, like mac for make. Let's consult our shortcuts. Mac means so there's no clues in my shortcuts that I can see immediately. Mac for make, I use that in some cases, but I think that's a Go thing, right? Make Golang. Or is that just a thing I made up? Oh no, func make. The make built-in function allocates and initializes an object of type slice map chain only. Like new, the first argument is a type, not a value. Unlike new, make's return type is the same as the type of its argument, not a pointer to it. Okay, so it's not a pointer. Got ya. So new gets a pointer and make does not get a pointer. So I kind of get why. So since there are no pointers in GLSL code, and also because this is on the stack, it would make sense to have it called make for MAK, right? So we could, you know, at vid IID 0093 time 0031, and let's just call this 40, right? And so right, so decided on Mac for make, or make as our constructor postfixed. Right, so that's our constructor postfix, and then we have like a justification for this postfix of make, which is that in Golang, make does not return a pointer, whereas new does return a pointer, and this exists on the stack, so therefore make makes more sense than new. So we'll call it mac for make, right? So we have this section called constructor macros. We should go up to the top of the type macros, right? We should have another section, the same name at the top, right? We do. And right here, we're going to paste the constructor macros section and declare what we need to declare. Yep. So we have two sections, right? So we have a if-def for if it is OpenGL, and then another section for if it's not OpenGL. So this is if it's OpenGL, and then else if it's not OpenGL, and then endif. Okay. So fv4 make if it's OpenGL, is just going to be vec4, right? We can use vec4 itself as a constructor, right? We don't need another function. That's all we need to use, right? Now, if we're here, though, we're going to need some type of polyfill. So I don't know what we're going to call it. I guess we call this polyfill texel fetch. So do we want to call it polyfill whatever the heck? I mean, if we want to be consistent, I guess polyfill is the best thing to call it. So, you know, AAC 2020, polyfill, make vec4. Polyfill GLSL make vec4. I don't know, something like that. So we'll take this, and we already have a polyfill section up here somewhere, right? So polyfill texel fetch, do not paste in a GLSL code. Do not paste in a GLSL code. So this is already double indented. I don't know why we did that, but since we already kind of double indented that, we can label this. So GLSL polyfill texel fetch. Alright, so this is a GLSL polyfill for texel fetch. And I think doing it like this might make more sense. Like, it's easier to go between one and the other if we do it this way. Let's paste the name of the other function we want right there. Yeah. And then here we'll just do GLSL polyfill, and this one will be called make vec4. That's just what it'll be called, right? So now we have another section for this polyfill. And we can so float vec4, this function here, I really should have named it something besides what I named it, but for this we're going to have to, if we use this constructor syntax, we can't do anything super fancy. GLSL does allow us to do some fancy syntactical things with how we can kind of chain together constructors. For example, you could make a vec4 by including two parameters, the first parameter being a vec3 and the next parameter being just a scalar. Or you could make a vec4 by just including 4 scalars, or you could make a vec4 by including 2 vec2s, right? So you can like combine things in a whole bunch of fancy ways, but we're not going to allow that because it would just make it harder to shim the code if we allow that stylistically. So we're not going to allow that, right? So we want to write our code in such a basic, plain way that it's a lot easier to transcribe or transpile into a different language, right? That's a kind of common thing with how I like to write my code. So yeah, let's so we know that we just need some type of float 32, and it's F32 actually we just want to call it FX, F32 FY, F32 FZ, and then F32 XYZW. XYZW is obviously kind of like weird, where you're like, why not, you know, W, X, Y, and Z, right? So why not XYZ, why not W, X, Y, and Z? Well, that's just the way code kind of works in shader language, because you know, you're usually when you do math, right, you're working with 3 points, the X, Y, and Z axis, and because of that, right, the Z is the last letter, so you can't really, what are you gonna do, right? So just tack on a W, right? It's you could almost say that linear algebra has legacy code in it, right? Like the actual conventions of linear algebra have like legacy problems, right? Where we can no longer refactor X, Y, and Z to mean something different, because X, Y, and Z have very specific meanings in linear algebra, and so we're kind of stuck with that ordering, and so here's our W for this fourth parameter, right? So float vec4, we need to declare what a float vec4 is, though, so let's duplicate this and do fv4 for float vec4, and then at the top we'll make another entry here. So right here, let's just duplicate this, say fv4, and float vec4 in the case of this code here is going to be this guy here, right? Because this is running in, this is a polyfill, so it always runs in the C code, right? So and I'm not sure if I like this kind of namespace, but let's be consistent with it, right? If that's what we've chosen, let's be consistent, right? And then if we want to rename it all later, we can rename it all later to something else, but for now, that's what we've kind of chosen. We can pick something later if we have something we like better. So, okay, so float vec4, and then fx, fy, fz, right? And to create this, we're just going to take this, one of these structs, but we need the constructor, right? Actually, no, we don't need to use a constructor. Oh, this is the polyfill. What am I talking about? This is the constructor. This is the constructor. So float vec4, fv4, okay, and just fv4.x equals fx, right? And just paste XYZW and XYZW, right? XYZW, XYZW. And then just return it, right? So, dead simple. Yeah, so now we got this little polyfill here. And here's where we're deciding if it's gonna, if the make function is going to be a vec4 because it's native OpenGL, GLSL, whatever, or if the make function macro is going to be this polyfill, right? And then where we're using that is we're using it right here to determine what the frag color is. And we're going to keep this code really dead simple for now. We're just going to do like 1.0 red, green. Actually, not green. Let's do like a magenta. And 100% for the alpha. Right, so we just want something basic, right? It's not a complicated shader. It's just something to get us started, right? So if we can get this running, in the C code, then we can cut and paste this modification into the shader, and our shader we're going to nuke some of the old code and kind of take a step back in a way. But things kind of get messier before they get cleaner. But yeah, we're just gonna see if we can get a magenta screen with this code, but also see that the code correctly compiles in the C code, right? And then eventually we might want to write some tests for this as well. Once we figure out what the behavior of this main needs to be, we could actually write some tests for it. Since we're going to cut and paste it into the GLSL, but it's going to run as C code, we can write some CPU side tests for it. So let's give this a run, see what kind of mistakes we made syntactically, and error, unknown type, name F32. So I know we declared it in some places, but we may be missing it in other places. So looks like 103 or 130. Yeah, so this float vec4 takes F32s, and we don't have F32 defined here. We got int 32, etc., but we don't have God damn it. But we don't have float 32. So we're going to go over here and just kind of duplicate this line and just make float 32. And this is the 7th parameter. And then up at the top, we'll have to add that parameter as well. So this will be a 7th parameter. And it'll be float 32. And this is always CPU side code. So it's just going to be float, right? So float 32 is float. And let's take that for a run, see if we can get that working. Unknown type name F. Sorry, hold on. The hell. Okay. Unknown type name F V4 Mac 176. Okay, well, let's look for it and see where we went wrong again. So on 176 over here. Oh, you know what this is? It's called We Don't Know What the Hell We're Doing. We gotta define these. Right? And then undefed properly though, so that's good. So error, variable frag color is set but not used. So that's interesting because in the GLSL code, I believe we never return it, right? It's just you set it at the end of main and then you're good, right? You don't have to actually return it. So if we look at, and we can see that from the old code. Like if we look at this version 1 code and we look at main, so here's main, and at the end of main, there's no return, right? There's no return in main. It's just, hey, set frag color, right? But when we compile this as C code, the C code looks at that and says, oh, you set the variable, but you never used it anywhere. So we need some type of shim or adapter pattern to kind of allow for that as well. So let's go in here and think about, well, how are we going to make that happen? So frag color, well, we could just make a no op for it, right? A no-op would be the easiest thing to do. Or we could say that this void, it could be GLSL void. Yeah, there's a lot of ways we could do this. How do we want to do this? Well, if we eventually want to write tests for this, then having frag color returned would actually be pretty useful, right? Otherwise, we can't return it. So what I think we might want here is a so we got these type macros, we got these constructor macros. Return value macros. I don't know how many macros I'm actually going to need that are return values, but undef ret main, maybe, ret, and then over here we can say that this is ret main, and in GLSL code it'll be void, and otherwise it'll be this thing here, right? So, instead of having too many macros here, right, we can just put this macro here and just say, you know, if this is not OpenGL, then return frag color, right? Return frag color. So if C99 C11 code, return the fragment color, right? So alright, so I think that is a good thing to do. Yeah, so rather than making another fancy kind of macro thingy for this, I think it's going to be a lot better if we just wrap it with this macro. You know, if this is not OpenGL code, if it's if it's running as C99 code, return the fragment color here, right? And then up here, this thing called ret main will be the return for main, and we'll do kind of something similar for that, where well, ret main only needs to be in one place, but I don't want too many of these if-defs kind of hanging out in the code. It just makes it a little bit harder, I think, it makes it more cluttery. I don't know. So, because we could just take this return type and we could just wrap it with the if-def or whatever. And maybe that's the best way to go. So, like, right, so we could do, you know, if def if it's OpenGL void, else if it's frag color, that's a float vec4, right? So float vec4 and if, right? So we could do this for the return type of this. But I feel like that just makes it kind of more difficult to look at, right? Because now we have this like weird cluttery thing. Now it is closer to where it's being used though, right? Because then we don't have to search around the file for what's happening. We can see it right here, right? What's the return type of this? We absolutely know the return type right here. We don't have to be looking in any other places. However, as far as, I don't know, the overall gestalt of the readability, I think, is hindered by that. So I think just calling it ret main is better. And maybe I am full of it. So let's go over here. Let's take this, and let's go look at the constructor macros section at the top, and paste our new section. And, right, we want kind of this kind of guard again, right? So we want a guard for, hey, if you're OpenGL, do one thing, and if you're not OpenGL, if you're C99 code, do another thing, right? So we'll keep the same kind of thing here. So we want to define ret main. If this is OpenGL, main just returns void, right? If it is not OpenGL, then it's a floatVec4, right? It just returns the floatVec version of everything. Now, do I really want everything to be floats? No, I don't want everything to be floats, but that's the way shaders work, so that's the way the C code's going to work as well. Now, that could create some problems with testing, because then we have floating point errors, and we have to, you know, think about the implications of, you know, how that works and all that good stuff. But this is how we'll do it. So define ret main, avoid if it is GLSL code. GLSL code. So this is GLSL code, and this is C99/C11 code right here. Okay. So I like that. That's, we're on to something here. So yeah, now that we have this return main, this is kind of ugly here, but some things are just going to get ugly. I don't know what to say. If it's OpenGL, we have to declare this. If it's not OpenGL, then we need to declare it, right? Is C99 code, right? So, right, little arrow here, C99. Also, this is, here, let's do that. Okay. So, I'm happy with that. Let's give it a run and see what else we screwed up. Or nothing. Okay, cool. So now that it's kind of, you know, it's compiling, the next step is to copy and paste it and throw it into our shader code and see if it will work, right? So now the other thing is we have some, it'd be nice to do it all in one go, to like not even need to have all this stuff too, right? Like have this in a section of code somehow, and you know, we could actually get away with that. So we could, right, so here, let's take this stuff here, right? Let's take all this stuff here, copy it, and then in here where we're kind of like doing, you know, if it's OpenGL or whatnot, we can write things that are completely invalid code, right? Like so GLSL file scope stuff. Very technical name. Yeah, we could paste this in here like that, right? And we could actually, that would be suitable. I mean, we got to get rid of the quotation marks around it, but we could do something like that, and its only real usage here is just to help us cut and paste stuff all in one go without having to worry about cutting and pasting the wrong parts, right? If we have everything we need to cut and paste into that shader code declared in this file, then all we got to do is cut paste from here into here and we're ready to go. And I actually think that would be very helpful. So that's the way we're going to try to do it. So this thing, you know, if def, and then we'll do over here, we'll do and if. And this thing, this define needs to be in here somewhere, and I know we put it somewhere. Define macro, this is OpenGL, so we kind of put it right here. Oh yeah, that is the thing, isn't it? So the first thing needs to be the version string, I believe. So we can't really wrap it like we want to wrap it, can we? Yeah, I don't think we can wrap it the way we want to wrap it. Yeah, we can't do that. It'd be nice if we could, but we just can't, because the version string thing has to be up there first. This directive, we can't really. Right, we have this here. Okay, so let's nix that, even though I really like the idea of just being able to do that, but it's just not gonna fly, I don't think. I mean, yeah, because this has to be the first line, I believe. If this is not the first line, things happen. So yeah, so we're not going to be able to get away with that. So hold on, let's make a note here. Can't shim. So we really can't shim this. So let's make a note of that. Of why we can't do that. And the time is... Right, so if you want to know why you can't shim this stuff, it's because this macro if is OpenGL. It's defined in here. Now we could move it out of here and surround all of this code. Right, we could have it. We could try to put it before all of this code, but the problem is that this version string needs to be the very first thing, so we wouldn't be able to do it. Now, well, we could probably do most of this, right? We could do, like, we could just say that, like, we could probably, if we wanted to do something like that, maybe what we could do, you know, maybe we could get most of this shimmed in. So what we could do is we could say, you know, we could take version 330 core, right? And then we could take this macro, right? This macro that we need to define. And then we're done, right? We got what we need to to cut and paste, right? So the only thing not cut and pasted from... Yeah, we could do that. So we could, like, right, we could just keep this thing here. And, everything below is cut plus pasted from the C99 file P5D OGL.that, right? And then we could take, well, we already kind of took this, right? We got the in and the out. We got all this stuff, right? So now we can start cleaning this up, and yeah, so actually we can shim this. We can shim it, just gotta be kind of careful about this. So keep sampler high. We could keep all this commentary. This define, we don't need the define, that's already somewhere else. All these characters here that we're surrounding stuff with, let's just get rid of all of that. And we'll have to clean it up. Okay, so yeah, so let's just kind of clean some stuff up here. So these are the uniforms, and we have uniforms for shader toy compatibility, and then we have the inputs and the outputs. So frag color is the output. The input is this fragment texture coordinate. I'm fine with that. That's fine. Now, yeah, if this is how we want to roll with this, then can we just seal this off now? Or is everything not quite... Yeah, we need something... We need to indent a little bit here. We need to... We're like one character out. We're one character too big here, yeah? Yes, we are, so... Right, so we can kind of seal this and never have to think about it again, right? That's the idea of what we did here. So this, the if-def should be kind of glued to this thing here. So yeah, we got this file scope stuff. So if it is GLSL, then we're going to include all this nice stuff. And even this define here. Oh yeah, I like that. And do we have this GLSL file scope thing anywhere else? We don't really need it anywhere else, do we? Yeah, we don't. We just need it at the top here, like that. So I'm gonna change that a little bit just so I can change my comment style a bit. So this is the shader toy compatibility section. That's fine. But what would be better is if everything was lined up nicely. So I'm gonna do this and then think about how I'm wasting time. Okay. So that looks good to me. The alignment part of me wants to do this, unfortunately. Okay, yeah, so now we just want to make sure that the code still runs, right? That pasting all this didn't do something weird, right? We didn't introduce any kind of syntax errors. Okay. Looks like it's still running. Okay, cool. So now the next step is to take this for a run, right? To say, hey, I'm fairly certain we have something, a good little payload here. And I'm confident that if we take it and we paste it, right, we paste all of this stuff into, the shader code, that it's just gonna run, right? That it's gonna work, it's gonna compile correctly, that we haven't made any mistakes. And if we have made some mistakes, well, then I don't know what we're gonna do. We're we're going to have to painstakingly figure out what we did wrong, and it's going to be really annoying and it's going to suck. But it has to get done, so it's not like we can say, oh, I wish I had done it better or whatever. Yeah, there's just, we're going to have to bite the bullet. So, but I think we're onto something here. So let's kind of nuke all of this stuff here and start over again. And this is a very annoying process that definitely would be nice to automate it somehow with like shader strings and whatnot, or automate it with it'd be nice to just automate it with a build system. But the thing is if I add a build system or whatnot, the code base is just going to be too complicated, and so I don't want to do that. So let's. I had all the code on my clipboard, but I want to change some things around, so we're about to lose the stuff on my clipboard because I want to kind of organize this in a way where the section of stuff that I'm not going to change is a little bit more obvious, right? Right, like something like this. It's like, right, that looks, why is that like that? Oh, I see. Now if I do 2, can I get rid of the problem? No, that just moves it over. Oh, it's because of this over there. I see. Okay. Yeah, so everything below is cut and pasted from C99, and if we want this to kind of like line up nicely since we got this gray, let's do that. There we go. That looks kind of nice. Let's color this as well. So yeah, default, whatever the heck. And we have the beginning and the end, and then we're just going to paste everything into here, right? So we're just going to paste it all in here. Alter this once we get project running again. Well, we're kind of already doing that, so let's get rid of this clutter here. Yeah, let's get rid of that clutter. Cool. So now we have this nice little thing where we're ready to just paste, right? We're ready just to paste this code, copy that to the clipboard. Right, it's already indented for us in a manner that is going to facilitate easily putting quotation marks around it. However, we've already kind of screwed ourselves here. We can't be putting quote marks elsewhere in our code if we're going to put it into a string, right? So we'll remove those quotes from there. And let's just look for the quote mark character in our source code here. Just make sure we're not doing anything stupid. Do not paste into OpenGL code. Well, that's the only other place it is, and this stuff is not to be pasted, so that's fine. Do not paste in GLSL code, this section as well. And then here's what we want to cut and paste, right? So, so really this section needs to be renamed because this section name is not the same thing that we want anymore. It is, if you really want to think about it, it is this, right? That's basically what we're creating. So we could name the section after this, So, because that's essentially, we're creating this string, right? So, let's do that. So, right? Cut and paste this into GLSL source, right? So now we got these section headers. Let's go up to the top and do the same thing and rename these sections, because the section names that we chose originally, those are no longer valid, right? So take these and right. And, you know, this name is going to help us know what it's related to. But we could also make a note, right? Just we could say, you know, paste into file P5D 001._, right? We could just give it another label like that, which now makes this like super kind of like ridiculousness. But you know what? If you think about it, it's not that ridiculous, because this is a big section, right? The bigger the section is, the bigger we want our little dividers, because it just makes it easier to kind of see what's going on there, right? Also, cut and paste into source. Is this correctly balanced? This is the outer one. I mean, that's fine if we want it to be the outer one. It's just that we need to be consistent with that, so... Right, outer. And paste into file. This is the innermost. Yeah, this is innermost. So yeah, paste into file this P5D, right? P5D 001, and this is kind of a hint to know the shader string name that it goes with. Cut and paste this into GLSL source, right? So we got this nice section name here. And then we are ready to take all of this, right? This is the process where it'd be nice to have a build system that kind of just cuts and pastes the file, right? Because then we could put everything here, we could put it in its own file, and then include it in different locations. But right now, we're just gonna kind of hackishly do this. So we're gonna take it, we're gonna paste it, and then once it's pasted, we're just going to surround it with boy, this is a lot of code, right? We're going to surround it like this. Why does it say PAINT5D get? We have kind of screwed up our labeling. We gotta go look at that. That's not right. OpenGL PAINT5D get. So let's look at that for a second. PAINT5D get. I have no clue how this section header. Well, I mean, originally that's what this whole section was for, but now it's just not. Really, what this is it's P5D001. Right. Let's give it kind of a label that is more indicative of what is actually going on now, right? So this label makes more sense now. And then go all the way down to the bottom of all this madness and kind of change that over here as well, right? All right. So there. So now we got this label at the top and bottom of the section. We're not going to recopy and paste this, though. But for next time we copy and paste this, we'll have this kind of better label here. So yeah, we have all this code now, and the difference between what it was before, the last time we tested it, is now we have, right, we kept the version 330 core as the first things here, which we're never going to change, but then all of the other file scope stuff, right, if it's OpenGL, then high precision sampler 2D, right, the different pieces of memory that we're going to look at, the different texture memory, Tau Depot and PAINT5D, things for shader toy compatibility. So this is for shader toy compatibility here and here. I don't know why I have... Yeah, I don't know why some of this nonsense here I'm gonna have to look at eventually, but if it works, it works. So let's not worry about this being complete nonsense right now. Let's just you know, try to get this new code working, right? Well, it's not complete nonsense. Define frag chord, GL frag chord. Right, so if when shader toy references frag chord, I need to use this. That's what that's for. Okay, it's not complete nonsense. Never mind. So yeah, we're gonna hope this kind of craziness just works. We're gonna hope that we can delete this shader and rerun it. I'm gonna guess we're gonna have some type of issue, but you know, I thought we added a very trivial amount of code. Well, the actual function logic wasn't trivial, but all the other, like, define crap around it was non-trivial, or... Okay, everything we added was pretty trivial, but it's just that we added a lot. Ooh, that was worse than I thought. No program defined. That is worse than I thought it would be. Now, is the program too large? Did we... I'm thinking that maybe main is not correctly defined. So let's find main. It said no program defined, so I'm going to guess that main did not... Oh yeah, main is not... there's no main. There's no main, right? We actually need a macro for this as well, right? This needs to be its own macro. So the return value, and then also this. So let's take this for a second. And yeah, so I see what's going on. So this will be, I don't know. Let's call it return main fun main. And then, actually, no. Right, so we can't obviously have another main function in our C code. So if it's GLSL code, we're going to do this. And Otherwise, define OpenGL PAINT5D main, and that's going to be the C99 version, right? So the actual function name now is defined in a macro. That's kind of weird, but right, we just need this kind of behavior so we can shim it in. And also, this is not right. Right. Ret main, fun main, right? So this is for GLSL. This is for C99. And let's not call this return value macros. Let's call it well, right now it's just main macros, so main shim macros. I'll just call it main shim macros. It's very specific for a category, but I mean, judging by the contents in it, that is the best name for it. So then over here, we're gonna change this to main shim macros. Okay, yeah, so first thing we want to do is we just want to confirm that we didn't do any stupid syntax mistakes, right? So we're just going to try to run it as is right now before we try to cut and paste anything. And just say, hey, you're running. And I would say that's running. We know that it's going to crash once if we select shader slot 1, it's going to crash. Right, it says no program defined. And that's because it had no main. So we're going to fix that now, because now we have these macros that will define the main function properly for us. So if we look at the fun main, let's make sure. Fun main, if it's GLSL code, if this is OpenGL, if def OpenGL, then fun main is just main, right? And we already know this one's working, right? We already know that's working. Because if we had 2 mains in our C99, it would not compile. Okay. So yeah, just a lot of weird stuff. A lot of weird trickery with the macros. But yeah, let's give that a shot and see if we can get this running. So I am liking this. I think that this is kind of like it's ugly. What I'm doing is kind of ugly, but I think from a theoretical standpoint of coding, I'm sure this is like ugly and horrible. From a pragmatic standpoint, I think I might be onto something. Yeah, so let's just go in here and let's take everything we just copied and paste it down and kind of reseal this. Yeah, this is very time consuming, though I don't really like that aspect. But we're hoping, you know, that once we have this basic renderer done, we won't have to go into it and edit it all the time. And if we do edit it, we're not going to edit it here. We'll edit the C99 code, and we'll be very careful to make sure that it works both as C99 and as GLSL, right? We'll try to make sure that it works in both cases. So let's take this and now we're going to hope that this actually runs, or at least doesn't crash catastrophically like it did earlier. So let's delete this. Ooh, that's... I don't see the file. That kind of worries me. Okay, well, let's just give it a run and see what happens. But I don't even see the file. Why is that? That's worrisome. because the file isn't even there to delete. And it should be on startup, it should actually exist. So that is not cool. Did we use is our function, like, is it too long or something? Or what did we screw up when we made this, right? Because, I mean, we got this care pointer, whatever the heck, right? We didn't change that. And yet something is happening. So let's take a look at this. So if let's rename this really quick. We're going to rename it to this is version 2, right? This is version 2. We're going to open up version 1 and rename it really quick. We're just going to rename this to version we're going to rename it like that. Right, so we just swapped them, right? Okay, so the idea is that we think something about the shader string is causing horrible problems, and we don't know what it is. So it's still not being remade. So I think that there's some type of file system access thing going on here. That's just not cool, man. But I think it has something to do with file permissions, and that this will get resolved if I... Oh wait, no, you're right down there. Hold on, what the heck? F5. No, you're right down there, right? Let's double click this, see what it is. Okay, well, first of all, we never deleted it because we thought it was already gone because it was, like, in the wrong... God damn it. So, let's delete this. And let's rerun, and we're going to get the old shader back. Okay, so I was expecting everything to be in order, numerical order, but because the new file was created, right, it got created, yeah, just, okay. I see what happened. I don't know why it did that, but good to know for next time. So, we're going to expect the old shader, and then we're going to swap the file names again, and delete the old shader, try it again, right? So, it looks like our... Yeah, so if we go over here, yeah, so here we are, back where we started. And we're going to delete this shader, right, so it can be recreated. But, over here, we're going to take this and we're going to rename it to version 1, right? So, 001, version... Right, version 1, and then version 2, we're going to rename it. So, rename. So, we kind of quickly rename stuff because we were wondering what the heck was going on, so. Okay, so now this will be the new source code for the shader, right? So, this is what is going to be embedded. This is embedded in the executable. And from being embedded in the executable, when the executable runs, it will instantiate it as the first one of these shaders. Okay, so let's give that a run and see if we can get this working. And then after that, we'll say that I'm going to take a break from this, right? So instead of doing really long streams, when I'm not really feeling motivated, I'm just going to try to do enough of a stream to get to like the next kind of checkpoint, right? The next little thing, right? Just nickel and dime, right? You know how you can, there's that saying of nickeling and diming someone to death, or the feather that broke the camel's back. Well, we want to kind of do the same thing, but in a positive sense, where we don't feel like working, but let's just kind of do a little bit work here, a little bit work here, a little bit of work here, and hopefully have it just add up, right? So, oh, excellent, excellent, excellent. So now we have this just magenta screen. Obviously, it's less than we had before, but it's a nice blank canvas that we can start writing that shader code for and get something awesome. Yeah, so we're going to hard code the camera position and whatnot at first so that we can what we could do is we could hard code the camera position, and we could put some type of default pattern into put a default pattern into the PAINT5D system, so that we have a camera position we can work with and a data set we can work with, so we don't have to worry about user input. That would be the easiest thing to do. So so let's do git bash here, git status, git add dot, git commits dash am, to do default pattern for PAINT5D editor, right? So this default pattern may be a temporary thing where once we have working code, we'll remove it. We'll keep the generation code in there just because it might be a nice feature. You know, sometimes painting on a completely blank canvas kind of sucks. So we'll keep the feature in there, but maybe on startup it won't initialize once we get this working. But anyways, okay. So in the spirit of doing things that we don't want to do, we could try to do more push-ups and whatnot as well. So let's look at the agenda screen. So start building default PAINT5D shader. We are doing that. That is kind of what we're doing right now. We need a I guess technically 11 default fill pattern for PAINT5D texture. So we need a default fill pattern, and then 12 we need hard coded so yeah, 12. So this is really annoying. Hold on, I'm going to copy this and put it into a better editor so I can edit these items in a way that doesn't annoy the hell out of me. So 11, 12, 13. So we're going to renumber these. Okay, now I'm going to paste this back in here. And our list is probably getting pretty big, isn't it? It's like, yeah, it's getting kind of like unruly, right? Where we got this P5D OGL test code. Well, here, let's go remove these two items, right? We're getting a pretty long list again. Let's just remove the items that we already crossed out. There we go. So now we still have room. Yeah, so we need a default fill pattern for the PAINT5D texture that kind of loads on startup. Some type of pattern that we can recognize and know what it should render as. And we're going to use that. We're going to use that to help us. Boy, there's like a lot of code in PAINT5D. I don't know if I want to put the default fill pattern in PAINT5D, but the pattern would need to be aware of the way we're packing the pixels, or the way we're segmenting the pixels, to be really useful. So I think we just gotta cram it into PAINT5D and be like, you know, PAINT5D is just a big system. I don't know what to say. So yeah. We'll hard code the viewport rectangles, viewport 0, viewport 1, and viewport C. Viewport C for the client area should always be snapped to the GL viewport. Viewport 0 is always the destination viewport, and viewport 1 is the viewport that is sampling from the off-screen data. And any viewport that's not viewport 0 is some type of off-screen viewport that's sampling some sort of data. I want to make sure of that for a second. VP0 means viewport 0, destination viewport. VP1 means is the off-screen, viewport 1 is the off-screen viewport. Okay, yeah. So that looks good to me in terms of what I need to do. We're almost at 2 hours. Let's look at our push-ups. Or, is it push-ups? Yeah, let's look at push-ups. So we're on Saturday right now. And if we can get 40 more done of everything, then we would be in good standing here to get our everything we need. So I'm gonna make a note to do 40 more. So I'm going to take this, I'm going to change this to 80. And then I'm going to change Saturday's total to 80 as well. And then I'm going to change the week total. I'm going to add 40 more to this. So if we added 30, that would be 600. So 610. Right, and that'll actually put us at 100 push-ups per day average. Even though we did more or less depending on how we were feeling. This stream, the current session is 1 hour and 42 minutes, and we're not really getting a big chunk of like 8 hours lately per day, but we're hoping that, you know, for the work we do, we're getting something meaningful done, right? Also, when we're not working, we are kind of thinking about what needs to be done next, so it's not like we're completely wasting all our time. So yeah, so we'll be